Hello, and welcome to today's lesson where we're going to work with right triangles and trigonomic functions. By the end of this lesson, you should be able to define the sine, cosine, and tangent function, determine side lengths using the trig ratios, and understand the usefulness of trigonometry to solve some real-world applications. So now, one of the most important things that you want to make sure when you're working through this entire unit is that your calculator is set properly in degree mode. If you're working with the TI-83, TI-84, the mode button is in the upper left corner. Okay, you would click on mode, and then it's usually one of the third or fourth areas down to switch back and forth between radian degree. We just have a basic scientific calculator here, okay, but notice that there is this mode button, okay. Calculators are normally set to radian mode, RAD, okay. There is a gradient mode and then the degree mode. You have to make sure that your calculator is set to degree mode. And we'll use these three problems here really quick to test and make sure that your calculator is set in the proper notation. So the first thing we'll do is we'll find the sine of 35 degrees. Now this graphing calculator is a little bit backwards because I have to type in the 35 first before hitting the sine button. If you're working with the TI-83, TI-84, you would type in the sine button, okay, right in the middle on the right-hand side. Type in 35 to get our answer rounded to the nearest hundredth. Okay, 0.57 for the answer. Okay, now when we're using these to solve problems, okay, I would actually suggest to go to what would be considered the 10,000th or the fourth decimal place to really make sure that we're getting one of the most accurate values we can for our answer. Okay, and then if we wanted to find the cosine of 45, 45 cosine. Okay, we get 0.7071. And then just to finish up this last calculation, tangent of 87. Okay, for a normal TI calculator, you would type in tangent first, then 87 and enter. Here I have to do this backwards. Some scientific calculators that are not graphing calculators work in this mode. Okay, and we get the tangent of 87 is 19.08. Okay, in this case, maybe not as important to add in those extra decimal places, okay, but you want to make sure that you're working through to get that value. Just want to double check this one. Okay, definitely a bigger value, still in degree mode, but you know, tangents can do that, especially as you get close to 0, they can get really small. As you get close to 90, they can get fairly large overall. Okay, so now when we look at trig ratios, the most important thing about the trig ratio is number 1, naming the sides properly, but number 2, know where you are standing. Okay, so if I'm going to label this triangle in relationship to B, okay, and that's always important. Where are you in this triangle? Because the labeling of the triangle is different whether you're standing at A or standing at B. The one good thing, the one thing that never changes is the hypotenuse. Okay, the hypotenuse is always the side across from the 90-degree angle. Now, when you're labeling your other ones, the other one I always label first is the opposite. Because if I'm standing at B, I look across to the opposite side. And then there's only one side left, and that would be the adjacent. Now, if I'm standing at A, okay, if you move and you're standing at A, notice how the opposite and adjacent would flip. Okay, opposite of A would be CB, and adjacent of A would be AC. Okay, but we're labeling this one in relationship to B. Okay, so we want to make sure that we don't move those pieces from where they're at right now. Okay, so now our trig ratios. Okay, the sine of an angle. Okay, so the sine of angle measure A equals the opposite over the hypotenuse. Okay, the cosine is the adjacent leg over the hypotenuse. Okay, and the tangent is the opposite over the adjacent. Okay, so now, when we're doing these based on this triangle and using the trig ratios, we can fill in these pieces based on what we're given and what we have triangle-wise. So if I'm using this triangle, I'm now standing at A. Okay, so label your triangle based on that. C is always the hypotenuse. A is the opposite. One thing I always do is sometimes I'll draw an arrow from the angle I'm standing at across to the opposite side. Okay, that makes B the adjacent. So if I'm looking at tangent, opposite leg from A divided by adjacent leg from A, this would be A over B. If I'm looking at cosine of A, the adjacent leg is B, hypotenuse would be C, and then if I'm looking at the sine, the opposite is A, and the hypotenuse is C. Okay, so that's how those would work in this triangle that we're working with here. And what you want to remember is this is the good mnemonic device, SOHCAHTOA. And one thing you can do is some people write it straight across. Other people write it this way. So the S is big because that is the sine function. And then the O over H. And then the C, A over H. And the T, O over A. So you can write it either way. But the SOHCAHTOA is probably one of the best mnemonic devices to remember the organization of the sine, cosine, and tangent functions. Okay, so now, in this case, okay, we need to find the missing side before we can build the ratios. So we would have to use Pythagorean theorem. 3 squared plus b squared equals 5 squared. Okay, so we've got 9 plus b squared equals 25, b squared equals 16, b equals 4. Okay, so now, where you have to use Pythagorean theorem to find a missing side if we have the other two. Okay, so now we can do our ratios. We're standing at A. Okay, so remember, label where you're at, and then set up your opposite hypotenuse adjacent. So if I'm standing at A, sine is, SOH. Okay, so I need the opposite length, 3, over the hypotenuse of 5. Tangent, TOA, okay, for our TOA. So for A, I'm standing at A, I need the opposite over the adjacent. Okay, notice this last one, cosine of B. Okay, so if I'm dealing with cosine of B, these opposite and adjacent pieces have to change based on my new starting position or my new reference position. Because now from B, 4 becomes the opposite. 3 becomes the adjacent. Notice the hypotenuse didn't change. It's always locked in. So for the cosine of B, cosine is adjacent 3 over hypotenuse 5. Okay, notice some of these relationships, and that's an important piece. The sine of angle A is equal to the cosine of angle B. Okay, now, one thing that we want to remember one of our basic rules, never use the right angle. You're only using the acute angles in these situations. Okay, so now, once again, here's a situation where we're missing a side length. So if we're missing the side length, then we need to use the Pythagorean theorem to find that value. So we would have 5 squared plus x squared equals 13 squared. And we can solve this down where x squared equals 144 and x equals 12. Okay, so we need all 3 side lengths to get true ratios for all of our trig values. Okay, so now the first 3, standing at x. So if we're standing at x, we've got our hypotenuse, opposite. Okay, the opposite is across from the angle that we're referencing, and then our adjacent. Okay, so always label your triangle and then use your ratios. Okay, so now we've got the sine of x, opposite over hypotenuse, equals 5 over 13. Cosine adjacent over hypotenuse, 12 over 13. Tangent of x, opposite over adjacent, is 5 over 12. Okay, now for these next few, what we're doing is we're changing our reference point. So we're no longer standing at x, we are now standing at y. And can we do this based on standing at y? No. Okay, y is a 90-degree angle. Okay, so since y is a 90-degree angle, we couldn't do this. Okay, what we would have to do is we have to change these to z if we want to find sine, cosine, and tangent of another value. Okay, so now that we know that we're standing at z, we need to relabel. 12 becomes the opposite side. That means that 5 has to be the adjacent side. As long as you can remember opposite and hypotenuse, adjacent only has one place that's left. So now for sine of z, sine is opposite over hypotenuse, 12 over 5, or 13, excuse me. The cosine adjacent over hypotenuse, 5 over 13. Okay, notice how they're just the flip of the sine and cosine of x. And then tangent of z is opposite over adjacent, 12 over 5. So it's just flipping the tangent of x. Okay, now, how can we use trig functions to find a missing value? Okay, so we want to see, where are we referenced? Where are we standing at? We're standing at the 40-degree angle. So we're going to label our triangle based on that angle. Okay, and you only want to use what you're looking for and what you know. So we know the angle, we know the adjacent, we know the hypotenuse. So if we know the adjacent is 15, the hypotenuse is x, the one trig function that uses adjacent and adjacent and hypotenuse is the cosine angle. So we need the cosine of 40 degrees equals x over 15. Now, if you remember, our entire second semester is ratio type problems. We use ratios for almost every unit, and this unit will be no different. We can turn it into a ratio by just putting 1 under the cosine of 40. And then all we do is cross multiply and solve. So we have x times the cosine of 40 equals 15. Divide both sides by the cosine of 40. And we get x equals, and now all we want to do is just type this into our calculator. What is 15 divided by the cosine of 40? So we've got 15 divided by cosine of 40 equals 19.58. Okay, now, one other option you have from the beginning is to start and plug in the cosine of 40.7660 and then actually use that as you work through your problem. 0.7660, 0.7660 divided by 0.7660. So 15 divided by 0.7660 is 19.58. Okay, so these answers are very close to one another. They're not exact. The most exact way is to use the full cosine as a part of your equation. If you're not going to use the full cosine, make sure you go to 4 decimal places with these values. Okay, so one more example here of finding x based on the given information. Okay, here is our reference point. So x is the opposite. This is our hypotenuse, and 20 is the adjacent. Okay, so I have an opposite and an adjacent of the 28. So if I use opposite and adjacent, x over 20, what I'm doing is I'm using the tangent function of the 28, and then I just want to put it over 1 and cross multiply and solve. Now, in this case, this is a nice, easy one-step, 20 times the tangent of 28. And remember, if you can, don't convert the tangent of 28 to a decimal value. Use it as its own value. But if you have to, okay, you can always convert it to a 4 decimal place value. So then we've got 20 times the tangent of 28, and we get an answer of 10.63 centimeters. Okay, now last idea here, just talking about the difference between what we have. When we use ratios of trig and set up proportions, okay, what are we using? Okay, we're using the trig ratios, we're using one angle and 2 sides. Okay, so when we're setting up a trig proportion, we're using one angle and we're using 2 sides, okay, and the ratio is based on which sides that we use. Okay, how is this different than the Pythagorean theorem? The Pythagorean theorem uses 3 sides and no angles. How do you know when to use trig and when to use the Pythagorean theorem? Okay, we can use the Pythagorean theorem when we have 2 sides. Okay, so we can use Pythagorean theorem when we have 2 sides and we're trying to find the third. Okay, we have to use trig when we have 1 side, 1 angle, and we're trying to find a side. Okay, so that's the difference between when we can use one of these situations and when we can use the other. Okay, so now last example, how can we see this in a word problem type? Okay, find the perimeter of Mrs. Johnson's garden. If the diagonal of the garden is 85 feet and it makes an angle of 35 degrees with one of the sides. So we know the diagonal is 85, and what we need to do is find x and y so we can find the perimeter. So now, based on where we're standing at the 35, the 85 is the hypotenuse, the 35 is the opposite, the x is the adjacent. So now we can set up two trig ratios. Okay, opposite over hypotenuse, y over 85 equals, and that's our sine function. Okay, so always remember whenever you're doing trig, you want to drop in your SOHCAHTOA to help you with those values. Okay, so when we're looking for the opposite, we know the hypotenuse. We're going to use the sine of 35, and then we put it over 1 so we can cross multiply and solve. If I'm looking for x over the hypotenuse. Adjacent over hypotenuse is the cosine of 35 degrees, and we put that over 1. Okay, so in both of these cases, we cross multiply. Y equals the sine of 35 times 85. Okay, x equals the cosine of 35 times 85. Okay, so we're finding these values overall. Okay, and what we're going to do here is we're just going to round to the nearest foot. So if I do this 85 times the sine of 35, rounded to the nearest foot is 49. And then if I want to find my x, 85 times the cosine of 35, I get 70. Okay, and that's rounded to the nearest foot, so we're doing a little bit of rounding here. Now, if I want to find my perimeter, and this is where you have to be careful, always pay close attention to the final value you're trying to get. Is it just a side length, or is it another measurement? So perimeter, 49 plus 49, or 98, plus 70 plus 70 for the rectangular garden. So we have 98 plus 140 equals 238. So we have 238 feet for the perimeter of this garden. Okay, and that concludes our lesson today, looking at the trig ratios, how we set up trig ratios, where we stand at reference-wise, and then using trig ratios to solve problems. Thank you, and have a good day.